Hey everyone, welcome back to the channel. This is Solo Coder. Today we are going to solve leetcode704 binary search. Before going to solve this, you have to know basics of arrays. For any kind of binary search problem, the first most thing that we need to observe is sorted order. It may be in the ascending or descending. So, um, before going to solve, first solve by yourself. If not possible, then listen this video. So for every binary search kind of problem, first he will give that the array is sorted. First check for for that kind of condition. So he will give the array is sorted, and he has given. So what he is saying means he will be given a normal nums array. You have to check whether the target index is there or not. If it is there, we have to return the index. Otherwise, we have to return -1. So, usually, how we will solve this problem? Generally, we will be solving this problem. Hmm. What is the brute force approach? Generally, we will think like we will take an array. We will traverse. We will take a for loop, and we will traverse it throughout the range. Like what's the range? Nums, len of nums. Of nums, and we will check each element. If a of the nums of I is equal to the target, then we will return the index, return I. Otherwise, we will return -1, as he said. But what happens if he do this directly? Means the code will be not accepted in most of the cases. Why? Why? Because he has mentioned that you have to solve this in big O of log n. That means you have to solve less than big O of n. Like I think you know like time complexity and space complexity. So for these kind of all program, it will be take big O of n. Why? Because we are traversing throughout the length of the array. That's why we will be. That's why the time complexity would be big O of n. So we'll not prefer this approach this time, but this should be correct approach. Okay. So let's solve using binary search. What does binary search actually does means it divides the array into two parts, where the each part is divided using mid. Mid means middle element. Mid is calculated through mid is equal to start plus end start plus end by 2. Like how we got this formula. Before telling how I got this formula, let me tell you like where we'll place like start and end indexes. So we'll place the start index at the starting point of the array, and we'll place the end index at the end index of the array. So as we placed here, and we will find the mid if the index of E and S, if E is greater than S, the entire algorithm will be stopped. So like let's understand up to here. So mid is equal to, like, we can write this formula, but most of the cases it will don't work. Like it will be stack overflow, this line. That's why we use this S plus E minus by 2 formula. It is same as this one, but we will not get Stack Overflow. Okay, and then let's move to this question. Sorry, let's move to new line. So like here, firstly what we will do means we will search the middle element. We will check whether the middle element is equal to the target. If not, we will check whether the middle element is greater than or equal to the target. If it is, if the middle element is greater than the target, we will just check from here to the middle element. If the middle else if the middle element is greater than the target, we will check from hmm, greater than the target. We will check from mid plus 1 to n minus 1. So, if the entire array is checked and the condition e greater than s has happened, even the maybe didn't get the target, we will just return minus 1. Okay, let's submit the code and check for the result. So here I missed the declaration part. That's okay. Okay, this is how we solve this leetcode 704 problem.
For any kind of binary search problem, first let's try run this code. So like, as we all know that the mid is equal to s plus start plus end by 2. So the s is at the 0 index and the end is at the n minus index, where n is the length of the array. So as you all know that the index of the array starts from 0, 1, 2, 3, 4, 5. So the length of the array is 6 and the last index is 5. So s is 0 and e is 5, 5 by 2. So 5 by 2 means 2.5, which is 2. So 2 means mid is 2. We need to go to the second index where mid is 2, and we need to see whether the a of mid matches with the 3 2 index. So 3, the target is 9. So it's not. So we will don't search this from 0 to 2. We will search above the mid. Like, why we are not searching the below part means, if the array is in sorted order, if the mid is not equal to the what we are expecting, then we will see whether the mid is greater than or equal to the target. Like, if 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 the mid is, like, a of mid is greater than the target, like, if it is exceeding the target, then we will search below from from 0 to that mid. Why we are searching from 0 to mid means, like, if it is already exiting, then we will be getting the desired element in within this range. If otherwise, we will search, like, def, uh, what will be the most obvious case means, if a of mid is less than the target, it would be in the range of mid plus 1 to n. So let's dry run and for most cases. So like, here we will be going from here to here. Why? Because index of 2, a of 2, which is 3, is less than the target. Less than the target. That means the target is in between mid plus 1 to n. So the next array, like where the index will be moved, means minus 1 0 3 5 9 12 0 1 2 3 4 5. So here the previously there is a mid, right? So now mid plus 1 will be this s is equal to mid plus 1, and then e is equal to same, he will be same. Like how it is done means, simply we will will declare s is equal to mid plus 1. So we'll just see this array. Again we will do mid is equal to s s is equal to 3 plus 5 by 2. 3 plus 5 8 by 2, which is 4, right? So here is the next mid. We will see whether the mid is equal to the target or not. A of mid is equal to target now. So we will then return the index which is mid.